Hello students, I appreciate you finding time in your weekend in order to get your notes copied down for Monday's class. As the title screen says, we are studying slopes of parallel and perpendicular lines. So let's get started. Your objective for Monday will be the student will discover the properties of slope for parallel and perpendicular lines. The date on Monday's class will be September the 30th. Press pause if you need more time to copy anything down, and then press play whenever you're ready to move on. Okay, now what is it about a line that makes it behave in a graph the way that it does? Well, when we first introduced the equations of lines the other day, we said that a line only needs two things in order to do what it does. It needs somewhere to start, and it needs somewhere to begin. Well, somewhere to start is just the y-intercept. It tells the line where to cross the y-axis. Everything else that the line needs, it is going to get from the slope value. So another way of thinking of slope is thinking behavior. The slope tells the line whether it's moving up as it goes from left to right or down from left to right, whether it's moving quickly or whether it's moving slowly as far as how fast it is rising, whether it's horizontal, whether it's vertical. All of that is behavior. That all comes from slope. So it stands to reason that if two lines are in a graph together, they are both behaving in certain ways. So if two lines want to be parallel in a graph, there's only one thing that can cause that. Their behavior must be the same. That means that their slope must tell them how to be the same. And if they are perpendicular, if they're going to cross at a 90-degree angle, it must also be the slope value that tells them how that behavior can happen. Okay, so here's how it works. There's two conditions that we're looking at. If two lines have the same slope value, then they are parallel. And I bet you could have guessed that without me even telling you, because again, if two lines want to behave in a certain way or in identical ways to each other, then they must have the same slope value. They must rise and run at exactly the same speed. Otherwise, they're going to cross each other at some point in time and they won't be parallel. Now, the one that is not exactly common sense is this one. Okay, if two lines have slope values that are negative reciprocals of each other, then they are going to be perpendicular. Now, negative reciprocals is a term you may be familiar with, but I think it will be new for many of you. Okay, the term negative means there is a sign change, and reciprocate is the basic translation is back and forth. Okay, so let's look and see how that's going to work for slope values. If I can get my computer to move the screen down, there we go. Okay, negative reciprocals, if it basically means if you take a fraction, turn it upside down or flip it, and then change the sign, it will make a new fraction. Now, if that fraction looks like the other slope fraction that you have, okay, then you have two fractions that are negative reciprocals of each other. And we'll look at that in detail here in just a moment. So if the definition is confusing you a little bit, don't worry about it right now. Let's wait for the examples and see if that doesn't clear it up. Okay, so here we go. Basic example. What do you know about the following two lines? Y equals 2x minus 5 and y equals 2x plus 13. Well, they are both in slope-intercept form. That is good. Y is isolated. Okay, that's slope-intercept form. Y equals mx plus b. We can read the slope values of both of these lines straight out of the equations because they're in slope-intercept form. So where do you look for slope in the equation of slope-intercept form? Y equals mx plus b. Where's the slope found? It is m, the coefficient in front of x. Okay, so in this case, both of the slopes are the same. They both have a value of 2. They are both rising 2 units, running 1 unit, 2 over 1, up 2 over 1, up 2 over 1. They're both doing the same thing. That makes them parallel. Now you notice that the top equation is going to cross the y-axis at -5. The bottom equation is going to cross the y-axis at +13. Where they cross the y-axis is not really a relevant discussion when we are talking about parallel. Parallel is just, are they behaving the same way or not? Okay, so they can cross at different places, and in fact, most of the time, parallel lines will cross the y-axis in different places. Another example, what do you know about the following two lines? Y equals 3/4 x minus 5, and y equals -4/3 x plus 13. Well, once again, they are already in slope-intercept form, meaning the y is isolated. So all we have to do is know where to look for the slope. And again, the slope is found as the coefficient in front of x. Well, obviously this time they are not parallel because the slope values are not equal. Okay, but let's have a closer look at these two fractions. These two slopes are going to be perpendicular. These two lines are going to be perpendicular to each other. And here's this negative reciprocal thing again. If you take one of the slope values, turn it upside down, and change the sign. Let's see what happens. Okay, so I took the slope from the top equation, 3/4, turned it upside down to make it 4/3, changed the sign from positive to negative. Is -4/3 the slope from the other equation? And yes, it is. That makes them perpendicular to each other. And once again, it does not matter where the equations cross the y-axis, one of them at -5, the other one at +13. Does not matter where they cross the y-axis. All that matters is that their slopes are negative reciprocals of each other. That means they are perpendicular. Okay, so what is the slope of any line that is parallel to the line 2x plus 3y equals 4? Okay, now we have a new problem here. When you run across questions that are talking about whether lines are parallel to each other or perpendicular to each other, things like that, you can probably expect that their equations are not going to be in slope-intercept form if the equations are given to you. Like this one. We cannot read the slope value out of this equation because y is not isolated. A lot of people will make the mistake of simply saying that the slope of this line is 2 because 2 is the number in front of x. The problem is y is not isolated yet. We can't read that slope until you get it into slope-intercept form. Okay, so we need to see the equation in slope-intercept form. So here we go. We have an equation. We are going to solve for a variable. So here's where my silly little saying comes in. Parents' complaints vary for every one. Okay, parents refers to parentheses. If there's parentheses or a distribution, we will need to deal with that. Okay, I do not see any parentheses in there, so we don't have to worry about step one. Parents' complaints. Complaints refers to combining like terms. Well, the only place where we have two terms together is on the left side. One of the terms is an x and the other term is a y. Those are not like terms. They will not combine. So they're going to stay apart from each other. Parents' complaints vary. Okay, vary refers to the variable that you're looking at. Now, pay attention. We have two variables in the problem. Only one of them is the one that we are after. We are after the y. So we want all of our y's to be in one place together. Okay, well, when you look at the equation, the y's are already only on the left, so we don't have to worry about that. Parents' complaints vary for every means everything else the other direction. So if all the y's are on the left, everything else needs to go to the right. We finally have something to do. We need to move those x's. Okay, so how do we move those x's? They are the lead term on their side of the equation. Okay, so all we have to do is look at their sign. They are positive. That means addition. So the opposite of addition is subtraction, finally. Okay, so we're going to do whatever we do to one side of the equation, we have to do to the other. So we're subtracting 2x from both sides. Okay, obviously the only thing that will be left on the left is the 3y's. What about on the right? We have 4, which is a constant, and -2x's, which are a variable. Will those combine to make a single term, or are they going to stay apart from each other? They're going to stay apart. constants and variables cannot be added or subtracted to make a single term, so they're going to stay apart from each other. Okay, and the final step of solving equations, parents' complaints vary for every one. One refers to having a positive 1 coefficient, positive 1 exponent. Right now we have 3y's. We don't want 3y's, we just want 1y. So we have to move the 3 but leave the y. So how do we split them apart? Well, what is happening between the 3 and the y right now? They're being multiplied. The opposite of multiplication is division. So we're going to divide everything by 3. Okay, that's going to leave us with just y on the left side, which is what we wanted. We now have negative 2/3 of an x, and we have a y-intercept of positive 4/3. Okay, now back to the question, what is the slope of any line that is parallel to this line? Well, now we can read the slope right out of the equation of the line. What is it? Y equals mx plus b. Slope is the coefficient in front of x, so our slope is going to be negative 2/3. Any line that wants to be parallel to this line has to have a slope of negative 2/3. Okay, what is the slope of any line that is perpendicular to 2x plus 3y equals 4? Well, this is the same equation we were working on just a moment ago, so we're not going to go to all the trouble to solve it again. We'll simply just pull it back up. Y equals negative 2/3 x plus 4/3. Only this time the question is, what is the slope of any line that wants to be perpendicular to this line? Well, that's where the negative reciprocals come in. So we're going to take our slope value, we're going to turn it upside down, and we're going to change the sign. So let's have a look. Our slope is currently negative 2/3. If we turn it upside down, that would make it negative 3/2, and change the sign, it would go from negative to positive. So any line that wants to be perpendicular to this one will have to have a slope of positive 3/2. Okay, this is where we're going to pick up in class on Monday. So go ahead and copy these two examples down. The first example says there is a line passing through points negative 5, 3 and 5, 9. What is an equation of any line that wants to be parallel to this line? And what is an equation of any line that wants to be perpendicular to this line? Copy this example down, leave you maybe 5, 6, or 7 lines worth of space in your notes, and then press play again, and we'll copy down the last example. And the example is, write the equations of the lines parallel and perpendicular to 4x minus y equals 3, assuming they have the same y-intercept as this given line. Okay, so that is where we're at for Monday. I do appreciate you taking time to get your notes copied down. As I'm sure many of you are figuring out, it is not just the grade of the notes that is going to help you to be successful in class. It is walking through class knowing what the notes presented to you so that you can be successful while you're in class. I'm glad some of you are starting to figure that out. The rest of you, I hope you come around soon. We're already 6 weeks down. We're into the second 6 weeks now, so we need to kind of get in gear if we have not done so already. I'll see you in class on Monday.